We have Tobias and Pontus from Omega Point. They're going to do a really interesting presentation about OAuth, I think, and how to do it or not. So help me with a warm welcome for these two gentlemen.
Okay, so thank you for the introduction and welcome everyone.
Yeah, my name is Pontus and I work as a security researcher and penetration tester at Omega Point, and I spend my days hacking systems and devices. And with me I have my colleague.
Yeah, Tobias, and I like to build secure applications, and we work at Omega Point Gothenburg doing penetration testing and security reviews. And together we have a lot of experience both building and attacking OAuth2 and OpenDConnect implementations.
Yeah. And today we will show a few things that can go bad in OAuth2-based implementations, even if you follow security recommendations and best current practices. And I just want to point out, if you're not following best current practices, you might have a lot worse problems than the ones we'll discuss today. So for this talk, we assume that you've done your work and you've done your homework as developers and architects and invested in a secure implementation.
Yeah, so maybe a little strong language there in the title, but it's kind of how it feels like when you realize you have a much weaker solution than you expect. And we hope that with this presentation, if you're like Pontus here on the offensive side, that you will get a better understanding on how OAuth is built these days. And if you're more like me on the defensive side, you will get a better understanding on the attacks and challenges we are facing as developers and architects. And in particular, we will highlight some pitfalls and weaknesses connected to the OAuth2 backend for frontend pattern. But first, we will do a little bit of history around OAuth2 and how we do secure implementations in 2023. And yeah, many of you might know the story and how OAuth has evolved. Over the years, there's been a lot of weak, custom flavored so-called OAuth login implementations, and big companies like Microsoft, Apple, Facebook have all done mistakes here. And to address these issues, there has been security profiles introduced, and one is FAPI, the financial grade for OpenDConnect. Even if it's called financial, it still applies to healthcare and other domains which has high security requirements. And then we also have the current best practices, or BCPs for short, and they are gathered in OAuth 2.1.
And there's a ton of specs online and good online reading materials, but covering all the flows usually requires about a 2-day workshop, and we don't have time for that today. But I really do recommend reading the 2.1 and FAPI specifications. They're quite easy to understand and digest compared to the core OAuth2 specification.
Yeah, and two things to note there to avoid some confusion maybe is that the BCPs in this presentation, it's best current practices for OAuth2, not the business continuity plans if you're sort of from the InfoSec community. And sometimes we just say OAuth, and by that we mean OAuth2, not OAuth1. And so to summarize all this, it has matured, and many system builds today use OAuth in some way. And the community around OAuth and OpenDConnect knows how to do this securely, even for systems in domains with high security requirements, like finance and healthcare. And just so you don't fall asleep while we talk about the specs here, we will give you a 2-minute version of the specs and to highlight a few things that are important for this presentation. And yeah. Here it is, so pay attention. When we do system integrations and no humans are involved, system to system, we use OAuth2 client credentials. And to strengthen that, to sort of be FAPI compliant and get this financial grade security, we should also use strong client authentication together with sender constrained access tokens. And we do that using mutual TLS, or if we don't like the public key infrastructure things, we can use a new thing called Depop. But both of them are just asymmetric crypto with the private public key pair for each client. So there's not that big of a difference. And we should always use short-lived access tokens. And if we have a third-party client, we should consider using something called reference tokens.
Yeah, and when we have a user with a web browser involved, the main flow is OAuth2 code grant with PKCE. But if you and to get user consent and delegate authorization to user resources. If you also need login, session, and identity, the recommendation is to use OpenID code flow, which is an identity layer built on top of OAuth2. These implementations can also be strengthened, just like the client credentials case, with strong client authentication and sender-constrained access tokens. For web applications, you should not have tokens in your JavaScript frontend, but instead opt for a backend for frontend component, which is a confidential OAuth2 client. And for financial grade APIs, you can also use a new thing called pushed authorization requests.
Yeah, so this sounds, well, maybe not easy, but at least it's well-defined or well-known, and you can read about all this online, of course. We will not explain the concepts in this presentation. So, if you've done all this, is the problem solved then?
Well, I wish I could say that, but in our experience reviewing and performing penetration tests of systems implementing OAuth, we can say that most of them do not follow the best current practices, or they follow best current practices that are no longer current. So the C in best current practice stands for current, and that's subject to change. So a lot of what we see today are systems still handling tokens in the front end. A lot of token services don't yet support pushed authorization requests, and the specification for PAR will most likely be finalized this year. So with that, we hope that adoption can increase. We also often encounter organizations that still use basic client authentication and bearer tokens, and that means that they're not able to do sender-constrained tokens.
Yeah, so security misconfiguration and insecure design are on the OWASP top 10 list for a reason. And but we should note that not all systems need to be financial grade, so it always depends on your sort of threat model and business. But the backend for frontend pattern is for everyone, but maybe not doing mutual TLS and sender-constrained access tokens or PAR. So that's important to keep in mind. But let's say you have done your homework, you've done all this that we talked about. Are you secure then?
Well, to answer that, we'll take a time machine and look back at a system implemented according to the best current practices of 2019, somewhere around that. And to be clear, this is what we, as me and Tobias and the security community as a whole, recommended 4 years ago to our clients.
Yes, so that means that there was a lot of clients built this way, of course. And so, remember 2019, before the pandemic, what did we do back then?
Apparently it was the best year ever, at least according to New York Times. But I wonder if that also covers OAuth2 best practices.
Yeah, so who hasn't updated their design and implementation since then? I mean, it's 8 years ago. So it's time for a demo, and we start with a little bit of context. And this is what the 2019 best current practices implementation would look like. And we have a token service, and then we have the APIs. And in a real-world scenario, we would maybe have 10 or hundreds of backend APIs here, but we have 2 to just represent that there are more than one. And the access model for the API here is that the low-privileged logged-in user should be able to get products and get their own orders, but not any other customers' orders. And they should definitely not be able to get all orders using the get all orders endpoint, which is meant for the order processor, a system integration. So keep that access model in your mind when we look at the demo later. And then we have the SPA, where the user logs in. It is all happening in the browser, so it's a standalone JavaScript client, which means that it's a public OAuth client with no client secret, because JavaScript can't keep secrets, so you can't use that. And that is doing all this OpenID Connect code flow with PKCE in the browsers. And there are, of course, a lot of arrows going back and forth between the browser and the token service. But we represent it with just one arrow here, and it's the get token request to make it clear that it is the browser and the JavaScript's front end that handles the token. So the request is there. And it's very common for those kind of frameworks to store the token in local storage. You could, of course, handle it in other ways, but that's a common practice. And also, one thing here is that in order to tokens are short-lived, but the user might need a long-lived session and can't be bothered to log in every now and then. So this means that you need to refresh the token. And the refresh token flow should not be used in public clients. So the security recommendations of 2019 is to use something called silent renew. And we will look into that a little bit more later. So that was the context. And the attack here is that the attacker wants to get all orders, and for that the attacker needs a valid token and be able to call the get all orders endpoint. So now, Pontus, let's see if you can steal some tokens from this SPA that I've built.
Yeah, let's have a look at that. I'll switch over to my browser, and next to it I have burp suite. I'll use that so that we can look at the network traffic between my browser and the single page application and the APIs. So first I'll just load up the application. To start using it, I first need to log in. Otherwise, I can't get access to any of the features. So I press the login button here, and I get redirected to the identity server.
Yeah, and maybe you're familiar with this, but this is the Duend identity server we use here. We just want to point out that this talk is not about any specific product or framework. We talk about general design weaknesses and pitfall valid for any OAuth implementation. But so there you could use many other products as a token service, of course.
And if I log in with my credentials here, press enter, I'm redirected back to the single page application. And there's a lot happening here. So if we scroll back a little bit in the network history, we post our credentials to the token service. We get redirected back to the single page application with a code. Now this code doesn't do us any good. We can't use that to access APIs. So what happens next is now we exchange that code for an access token. So we send the code back to the IDP, and we get back an access token. Now that we're signed in, we can call any APIs. We have a get orders, get my Swedish order, and I can also do product search by ID. We can look at the API requests here, and we can see that there's an access token attached to those requests.
Yeah, and we can also note that the API calls are directly to the backend APIs hosts.
Exactly. And so you asked me if I can steal a token. And one way of stealing a token is if I can find a cross-site scripting vulnerability so that I can execute arbitrary JavaScript under context of this origin and the victims session. And fortunately for me, this application is super vulnerable through the search field here. So it renders anything I put in here. For example, I can put a U tag, and you can see it renders as underscore here. So what I want to do now, in this application, I could just go into local storage and fetch the access token because it's in there. Sometimes developers try to hide that code or just keep it in memory, so it might be harder to figure out where it is. So what I'll use instead is to leverage the silent renew flow. And we have really short-lived access tokens for this application. And you can see, if you paid attention to the burp window here, that there's a lot of things happening. And so there is a silent refresh flow happening. And we can look at the, let's see if we can find the authorization request here. here it is. So this, what silent refresh is that the application opens a hidden iframe, which loads the authorization request to the IDP, which has the single sign-on cookie already. The single sign-on cookie gets attached to the request, and we get back a new code and can do the whole exchange process again. And since I can now execute arbitrary JavaScript on the context of a client, I can do the same thing basically. So what I've set up for this demo is an attacker server that hosts some a JavaScript payload that will do exactly that: create an iframe, get the code, and then send that code back to the attacker server and exchange that for a token. So I'll just copy this payload, paste that here, and it all happened quite fast. But what happened on the attacker server, we received a code which was then exchanged for an access token, and I can now use that access token to call the APIs on behalf of the user that I attacked. And this is one of the reasons why we no longer recommend using access tokens in the JavaScript frontend.
Yeah, so what Pontus just showed there is that we can't really hide tokens if the attacker can run code in your application. If you want to look more on this subject, there was a great presentation from Philippe Derick from NDC Security earlier this year. But now, how can we fix this? If we instead follow the best current practice of today, and the most obvious thing here is, of course, to move things to the back end. Here we have refactored from the 2019 SPA to a backend for front-end design. And the SPA is almost exactly the same, with one big difference here is that it's now served from the backend for front-end, which is a backend component. And all OpenID Connect stuff, all that complex JavaScript code has now been thrown away, and everything has moved to the backend. So as you can see here, the token request now is from the backend to the token service. So there are no tokens in the front end anymore going through the browser, which is good. And now we protect the session to the backend for front end with a classic secure cookie session, and that really is secure. I'm not joking. so there's no issues there. And yeah, and then to make it even harder, so now you have no tokens in the front end, which you can steal. And to make this even harder, we have also followed the best practices with using a gateway or firewall or something. We heard a good talk yesterday and about not exposing things on the internet if they're not supposed to do that. So we do this properly now. And so now the backend APIs, they are not even exposed to the internet anymore. The only thing there is the backend for front end. So now, Pontus, I dare you. Try and steal tokens. No, I double dare you.
Let's go back to our browser. I'll first log out here and load up the 2023 single-page application. I'll just clear my history here so you can see the new things. Again, I need to first log in. I'm redirected to the IDP. Sign in as Alice again. This time around, we still get a code back when we are redirected back to the application. However, there's no token exchange happening between my browser and the backend or the token. And when I do API requests like this, we can see them here. There is no token in these requests. However, there is the session token that Tobias mentioned.
And all the request goes to the backend for frontend, not to the API hosts. That's exactly.
And this token is marked as HTTP only, meaning that even if I have an XSS vulnerability in this application, I cannot access that token. If I do document.cookie, it's
cookie.
So the cookie is not available to JavaScript. So even I do document.cookie, I get an empty string back. And we can try. I mean, you saw that we do get the code, so we can try to exploit the same kind of vulnerability we did the last time. Doing that, copying this payload, just entering it here. We do get the code, but when we try to exchange that for the access token, we get an invalid client error. And if we look at the error message from the IDP, which happened to be in the window above here, we see that the client secret validation failed for this client. And that's because I simply don't have that client secret.
So that's the strength of having confidential clients, which do client authentication.
Yeah. And so now I'm not able to steal an access token, which is really good. However, since we're still vulnerable to cross-site scripting, I can still do what's called session writing. I mean, performing requests just like the user's browser would do through the user's browser. I mean, however, that's sort of a more constrained type of attack. And as soon as the victim user navigates to another origin or closes the tab, I'm out. I can do anything. So that heavily limits both the time and the opportunity that I had to actually do anything.
So even if we use this pattern, we must still protect against the cross-site scripting, because that can be really bad for us. And but we have this third endpoint, the get all orders endpoint, which you should not be able to use from this user session, even if you can sort of do session writing. So let us see if you can do that.
Exactly. Let's try again. If we look at the requests towards the BFF here, we can see that they go to orders, API orders. So that's them hitting the BFF and them getting redirected. By repeating that request and modifying the request URL, I'll just add /all here and send that, and boom, I get all orders.
Not good. All our defenses. I mean, how was this possible? We had the firewall and everything, and the backend for front end, and you didn't even have to steal a token for this, to reaching this more high privileged endpoint. And you bypassed all our defenses by just changing the router. And to analyze this, we go back to the system design and back to the slides. And so if we follow the best current practice of today, this is what we get. And as I said, all compliance checkboxes, they are green, and we have a solid, secure design. But the negative test case, the user should not be able to access system integration APIs, like the get all orders API. It fails. So why is that? What enabled Pontus to do this attack? And if we take a closer look and start looking at the routing here, which seems to be an issue, a common default way to configure reverse proxies and like the backend for frontend here is to do like this. And it looks so. What if we look at this? It's just conceptual sort of configuration. So what's the issue here?
Yeah, if we look at the match and path statements here, you can see the *any. That acts as sort of a catch-all routing, meaning that all requests towards the orders API get forwarded through the backend for frontend, even towards the sensitive endpoints such as the get all orders, which should not be accessible for normal users, and especially not for attackers.
So it's of course great for the sort of developer experience and availability to make things work out of the box. But if you think of confidentiality and integrity, it's not that good, because it's hard to keep control over which endpoint you can reach with this star pattern. And so if we go back to the system overview and we look at the backend for frontend design, the backend for frontend's job is to proxy request, and it's quite common for an API host or a microservice to have endpoints for both users and admins and system integrations all in the same host. So even if the proxy that we looked at had an allow list for which host they can route to, that may not provide any protection, because if you're on the same host, then you will get there anyway. But I mean, it's still just APIs, and back in 2019, they were all public. So what's the problem?
Yeah, well, the BFF, backend for frontend, has really two responsibilities. Besides just routing and acting as a reverse proxy, it also attaches the user's access token to all requests.
Yeah, and so once again, why is that so bad? I mean, as long as the API does proper access control, it shouldn't be an issue. So the question is, does your average API do proper access control?
Unfortunately not. I mean, at least in my experience doing penetration tests of APIs, we almost always see improper access control or authorization. And the OWASP top 10 list shows the same thing with number 1, 2, and 5 all being about authentication, authorization, or access control in some way.
Yeah, and in this backend for frontend scenario, it's also quite hard for APIs to do this right, because it could be a quite powerful token that gets attached to every request, having sort of the scope for all API hosts or a part of it. So it's not that easy to get it right if you just base it on scopes and tokens. And so besides the access control here, there are other things to consider as well. For this attack to be successful, we actually need 4 things to be present at the same time.
Yeah, and the first thing is that we need a valid session, and getting that as an attacker can be super simple. If the system has public sign-up, you can just register an account. And otherwise, there are all sorts of ways of getting access to an account and a session. For one thing, phishing credentials is a problem for any large organization. And as the old saying goes, hackers don't break in, they log in. We also often encounter backend for front-end components that have unfeathered access to internal networks. I mean, who does network segmentation in the cloud? We also very commonly come across this type of catch-all routing that just forwards any request using wildcards to internal services. And finally, in every system with large enough complexity, we find access control bugs.
Yeah, so it might seem unlikely that all these things happening at the same time, but it really isn't. So it's definitely worth considering as a risk. And before we look closer on this, we want to point out that if you're not following the best current practices, you might have much worse issues than this that we are talking about right now. And so how can we do mitigations to lower the risk of this?
Yeah.
And as always, sort of this sound security design principle will help us and guide us. And we have the zero trust and least privilege for the API here that tells us that we must do proper access control regardless of any infrastructure protection. But we should also build defenses in multiple layers, defense in depth. So we should also have a firewall or a gateway of some sort in front of us, giving us some basic protection. How to build secure APIs, it's a talk of its own, and we just want to highlight one thing. Be careful and do not base admin or system integration API access on just a valid token and scopes. Use something more like maybe client ID, grant, or authenticator method, because scopes they sort of tend to give more permissions over time, especially in larger organizations. And infrastructure and network layer security is also out of scope for this presentation, but we should note that we should use this, of course, and we should not expose internal APIs to the internet just because the cloud makes it so easy for us. So proper network segmentation is important for defense in depth. And we could solve this problem introducing more hosts and doing proper network segmentation, of course, but it might not be possible for us. And given defense in depth, we shouldn't rely on that. So we should have multiple layers of defense anyway. And so we will look more closely to the routing here. And see what can we do to strengthen this.
Yeah, and the solution is quite easy. It's about specifying the exact method and path used for all endpoints that should be reachable through the backend for frontend. This is super easy to do, but it might be a little bit tedious when you have a system with more API endpoints than just these two. But I really do encourage you not to try to be clever here and fall back to wildcards, because they will bite you in the ass eventually.
Yeah. So with this change, we get the following overview.
Yeah, and now we only have the specified endpoints with the exact method and path match. So we can only actually reach the get product by ID and get my orders endpoints through the backend for frontend. There is no way to access the get all orders endpoint through the backend from frontend with the user's session.
So with this, we have shown how to build a secure OAuth2 or OpenID Connect implementation following the best current practices of today, and how to avoid common pitfalls and design weaknesses. So this time, the good guys win. And it's time for us to summarize.
Yes, so this is sort of how to not fuck up at OAuth while following the best current practices.
Yeah, and the first thing we want to point out is that please read and follow the best current practices. It's just as simple as that. It's good guidance, and they are actionable and also easier to understand than the original core specs of OAuth.
Yeah, and then we want to point out to stop handling access tokens in JavaScript frontends. They cannot keep secrets. Instead, start using the backend for frontend pattern with a confidential OAuth2 client, and use a strict allow list. Don't let your backend for frontend be a vector for authenticated service-side request forgery. And as always, implement proper access control in your APIs, and implement proper out-output encoding and put other types of defenses so that you're not vulnerable to cross-site scripting, and do other types of application security defenses.
Yeah, that was it. And if you want to know more about this and application security topics, we have written about it at our blog there at securityblog, omegapoint.se. Yeah, any questions?
Any questions from anyone? Yes, in the, where? Over here, okay. Let's see, who was it? There we go.
Good presentation. How will you handle long-lived sessions then?
Yes, so the long-lived session, the backend for frontend, it will also get an access token and a refresh token. So that's the refresh token flow. So let's say you have an access token that maybe you have lives in 5 minutes, and then you have a refresh token which you can use for an hour maybe, and then do re-authentication. So that's so you need to keep that in sync with the cookie session that you have. So that's also need to have its max length and its sliding sort of inactivity timeout. It could be a presentation of its own, but then you also need to make sure that that is in sync with the single sign-on session to the identity server as well. So it gets a little bit complex there, but
yeah, and just redirecting the user back to the IDP with an authorization request, that for the user it just sort of happens very quickly and just blinks for them, so that can happen quite easily.
But it's interesting. So it's very good to test that logout actually works, that the session really ends, because it's quite hard. It's easy to do single sign-on, but it's hard to do single logout. Yep.
All right.